Chapter 5, Number 36. You pull upward on a stuffed suitcase with a force of 105 newtons and it accelerates upward at 0.725 meters per second squared. What are the mass and the weight of the suitcase? So we definitely want to start off here with some sort of picture. So here is our suitcase, and we are pulling upward with a known force. So we will apply to the force to the suitcase is that force, which is our pulling force, which we know to be 105 newtons. And at the same time, we know that the thing accelerates upward with an acceleration which is 0.725 meters per second squared. What we've left out, though, is that this was not the complete free body diagram. In addition to the force pulling upward, the Earth is still always going to be pulling downward. So our free body diagram actually looks like that. From the diagram, we can get an expression of the net force. The net force in the y direction, because we'll take our standard y and x axes. So our net force in the y is going to be the pulling force and the weight, but the weight acts downward, so we should use an opposite sign for that. And then from Newton's second law, we can get a different expression for the net force. The net force in the y direction is always going to be the mass of the thing times the acceleration in the y direction. And theoretically, those two things together should give us enough information to get an answer, although we'll probably have to use at some point the additional information that the weight of any object is its mass times the free fall constant. And putting all of that together, we can get a final expression for what's going on here. And we can say that we can connect this expression for the net force to this expression and say that Fp minus Fg is m times a. And then we can put in this here, so we can say that Fp minus mg equals ma. We're trying to isolate m. We want to find the mass. So I'll do that by bringing mg to the other side. And we'll be left with Fp equals mg plus ma. I will factor out that m, because again I want to isolate it, and then I will divide by g plus a, leading to our final equation being that m equals Fp over g plus a. So it's the 105 newtons over 9.81 meters per second square plus 0.725 meters per second square, which comes out to be 9.97 kilograms. Newtons over meters per second square is, of course, kilograms. And then that's part A. And then at the very end, our part B, which is going to be very easy, says, let's go create a little bit of space for ourselves. Part B is just that Fg, the weight, is m times g. So it's 9.97 kilograms times 9.81 meters per second square, and we get a 97.8 kilogram suitcase. And there we are.